course, hopefully fewer people completely hate poor little cubes. Right? It's not that bad. Little dude, big dude. What goes in a little dude? Good, x minus 2. So you square that, put it there, you square that, put it there, and then you multiply these. And then put that there. And of course, it's got to be different signs so it can do its job. I never really thought, that's so funny, I never even really thought of it that way, even though it applies. What are you talking about, John? 2 of these. So what goes here? 2 of these, none of those. What goes there? 2 of these, none of those. What goes in the middle? Aw, 1 of each. I mean, I like that. Maybe let's try to incorporate. Did that make sense, what I just said? Do you think that would help people remember it? I don't know. Sure. So x equals 2 is an answer, right? X minus 2 equals 0. Or this should equal 0. And what kind of answers do you think you're going to get from this? Complex. You're going to get 2 complex answers. So x equals 2. And then how do you do this then? Well, you can't factor it, right? You can never factor the big dude, so you have to use quadratic formula. Cool. So do that real quick. No, you can. But quadratic formula is a shortcut. Sometimes that shortcut actually takes longer, but if you like completing square, you can do it here. All day long. Let me catch up to you guys. Negative b, give or take, square root of b squared minus 4ac, all divided by 2a. You get negative 2, give or take, square root of 4 minus 16, negative 12. Negative 2 plus or minus, you can simplify this, yeah.
12.
Yeah, square root of 4 is 2, square root of negative 1 is I, and you have a 3 left in, right? 12 is 4 times 3. 3 gets left, square root of 4 is 2. Oh, you guys didn't like that one. Just simplify rad 12, right? Rad 12 is rad 4, rad 3.
Oh.
So it's 2 rad 3. And then the negative inside, you can write it as I. Square root of negative 1, I can write it as I. All divided by 2, so all the 2's die. Negative 1 plus or minus I rad 3. So that's certainly something we could all do, right? So you have a cubic equation. There has to be 3 answers. Now, real quick, I'm about to do something, and I apologize in advance. Maybe some of you guys are going to get some of this idea. Do you remember back when I first started talking about complex numbers and talking about how they were like half a term, stuff like that? So notice how one answer we got is 2. The other answer is negative 1 plus I rad 3. It's going to be like here, and the other answer is negative 1, let me put it here, and the answer, the other one is negative 1 minus I rad 3. These are going to be equal angles apart. So this angle here, and this angle here, and this angle here are all the same. So they're 120 degrees apart. All right, I'll stop. So that is some neat shit. I don't know if anybody understands it all. But the idea that I is a half turn, and do you see how this has got I stuff and real stuff in it? It's a mixture. So it's something in the middle, right? I don't expect you to understand what I just said at all. I just wanted to give you a complete picture. Does this matter? No. For us, You're done here. Everybody should be able to use quadratic formula. You should be able to do that problem. I like it. Blah, blah. Oh yeah, okay. Anything else from anything else? You guys want to do some more problems? If you have a general question, yeah.
We do 11C.
Yeah. So now we've kind of expanded the thing we used to also work for complex numbers. So what is it going to use on a problem when the bottom has two terms to it? Yeah. So what would I multiply top and bottom by? Right by plus 1. I like it. And again, it's always going to be kind of a difference of squares pair of things. Because we want to force the middle term to die, because that's the one place a radical would still be left alive, but we kill him. So on the top you get a bunch of shit, but on the bottom you get 5 minus rad 5 plus rad 5 minus 1. So on the bottom you just get 4. Holy shit. That's freaky. And on the top you get rad 10 plus 3 rad 5 plus rad 2 plus, you just, nothing's going to be like terms, you just foil that bad boy out. I like it. So, I mean, if the problem would have instead been 2I plus 3 over 5I minus 1, you would multiply by 5I plus 1, top and bottom. Because that is a radical. It's the exact same idea, to be honest. I is a radical. I do be a radical. My grammar's bad. I is a radical, so I'm going to treat, I can pretty much do a lot of similar things to it. It's a little bit of a freaky radical, because it's got some weirdness, but it works still a lot the same. Yeah?
Can we just keep it like that instead of foiling it out? The rad 2 plus 3 times...
No, you better foil that bad boy out. Otherwise, it's not really simplified. Yeah. Now, can I? Yeah, I can. No, but what would it be? It'd be rad 10. Yeah, just do it. I just got bored. Yeah.
So for question number 12, A and B, when you say find the domain of each function, you mean inside the root cannot be negative, right?
For which one?
Well, for B, let's say for B.
Oh, for B, what's true then? For B, what's true? It's a cube root.
Oh, it's cube.
So then domain is
All
all real numbers, right? The odd roots, very laid back. They can handle negatives inside, they can handle negatives coming out. Even roots, very uptight. Right? Oh shit, they can't handle negatives or else they become all this complex weird shit. Negatives can't come out of them. Yeah. The reason on number 12 I asked for the domain is basically a graphing problem. But like, what's the domain of 12a? Yeah. 2x plus 4 greater than or equal to. So you get, if you do this, you subtract 4, divide by 2, you get x greater than or equal to negative 2. Now, I didn't just do that, you know, domain and graph, haha, whatever. No. Once you find the domain, it helps you make a table to get the graph. Because what do you know you're going to start at? You're going to start at negative 2. That's the first thing you're going to plug in. You know where to start. And you know it stops there. You don't put an arrow through it. You know that's where the thing stops, right? Or starts, either way you want to look at it. So I will make an XY table of negative 2. Start there. And then I got to be a little bit smart about the other numbers I put in there to have nice square rootable things coming out. Let me give you guys the answer key. It's in 2 parts because it's so freaking long. Oh, here's the other part. Okay. Okay. Maybe on Wednesday I'll get to see everybody again. Yes.
Number 2C, it's not real because it has a negative outside.
No, it's not real because it has a negative on the inside.
Inside.
Yeah.
Oh.
So this I could do all day long. Because what's the square root of 16?
4.
So that's negative 4. In fact, that's the negative root. There's 2 square roots of of most numbers from 0. That would be the negative root, the principal root, and that would be the negative root. So that would be negative 4. This would be 4i, but I said use real numbers, so
Okay.
not real. Yeah. Even if you put a negative on the outside, doesn't do anything to help. Yeah. Let's see. Yeah, on the matrix one, hopefully you can somewhat follow along, but I try to do show everything, but also do it semi-quickly, so I did 2 things at once each time. So, do you see how above the first row it says 2, negative 4, 8, 16? So that was related to twice row 1 plus row 2. And then I did negative 5 row 1, so below it I wrote what it would be if I did negative 5 times that, and then I added it to row 3. Because I'm always trying to kill this rest of the things in the column. Now, the mistake people make is they'll get the first column done, and then they'll get a 0 in the second column, and then they'll try to do something with the third column, and they lose that 0. And then you keep kind of, I lost the 0 and then it's back, and then I lost the 0 and then it's back, and what the hell? Right? So, but if you just finish the first column, finish the second column, finish the third, that's not going to happen. It's not going to happen because then you make these zeros that don't screw with anybody else. Okay, maybe.
I have a problem understanding the absolute values. Like, I have the right numbers, but I don't put the absolute values.
Oh, so like where I have like
For example, number 2D,
yeah.
I had x plus 6 without absolute value.
Oh, 2D?
Yes.
Oh, okay.
Uh,
But the problem is, if you say this and you don't know what x is, could x be negative 20? Totally. And then this would be negative. So if you have an even root and the result could be negative based on the value of a variable, you throw that bad boy in absolute value.
the same thing on 3D. I have 5a over 6w5
Yep.
with no absolute value. So
Yeah, but since that was it was a square root, the result could be, based on what a and w are, they could be negative. Now, if you do this, I put 5 absolute value of a, right, on the top, blah, blah, blah. If you put absolute value of 5a, That's fine. It's just that the 5 doesn't need an absolute value. It's already positive. But these are the same. Because the 5 doesn't care if it's in or out. It's positive already. It doesn't care. So if you put that instead, that's fine.
Can you do 3F?
3F?
Yes.
Okay. So sort of the step I skipped, they're both square roots, right? So I can go ahead and just take one big square root and then reduce the insides. Right? When am I allowed to multiply or divide two radicals when they're the same root, when they're the same index, right? When they're square roots or cube roots. They're both square roots. So 98 divided by 2, 49. D cubed divided by B. So really what I'm really doing is, you're just looking at that first piece. I have square root of 98 divided by square root of 2, right? Yeah. Forget the D's and E's. I just make this one giant square root. And then I can make it 49. So now you can do the D's and the E's. And then at the end, take the square root. Yeah. Since they're both square roots, I'm allowed to just go ahead and do them. Divide them, multiply them, whatever it is I need to do. Yeah.
Can you explain the word problem, number 9?
Oh, okay. The key there is to draw the picture well. Physically, do you understand what's happening? I want to create this area for my dogs, right? So that I don't have a chinchilla or a pet pig or orcs. I just decided to just get regular old dogs. And I'm like, I can use the back of my house as one part of this thing that will keep them in this area, right? So they don't run over to the neighbors and harass them. You with me? So I'm going to use one part. I want to make this, but this side is going to be my house. My house is already there, thankfully. So I don't need fencing here. I need fencing here, here, and here. But how long is this? Doesn't say. We don't know. We know total how much it is, right? 36 feet.
36, yeah.
But how long is this? I don't know. Say again? X. I love it. So how long is this got to be then? X. And how long is this? We don't know. But it's not X also. I didn't say it had to be square. I just said it as a rectangular pen. So how long is this? Y. Let me stop there for a second. You guys, I can't make them all X because then you're assuming too much. You're saying that they're all the same, and then it's just 36 divided by 3. Ooh, it's not. But that's assuming way too much. I want to have the maximum area, so I want to let this side float. So really, do I want to make one that looks like this? Weehaw! Or make this side really long? Or do I want to make this side really short? So really, it's kind of like all about this side. How long or short do I want to make it so that the inside is the biggest area? It's not going to be a square this time because one side is not needing fencing. So it's kind of neat. It's kind of interesting. So, what do you know? What's the relationship between X, X, and Y? You just told me that how much total do I have to use? Fencing.
36.
So then how does 36 factor in?
X times Y.
So that's the area. They asked me about the area. Well, what they tell me about the perimeter? What's the perimeter? 36. But what's the perimeter from the picture? Perimeter, of course, means what do you do with your sides? Add them. So I have 2x plus y is 36. Let me stop there for a second. Especially if you get into pre-calculus, you're going to see this even more, this kind of thing. But here's what they tell me. Here's what they ask me. Do you see how this helps me out here? What can I do with this that will help me out with this? Bless you. What can I do with this that will help me out with this? Yeah, solve for y and then plug it in. then I'm going to get a parabolic thing. I can find the maximum then. It's going to be a downward parabola. You'll see the vertex will be the max. So for those, what we call optimization problems, we're trying to optimize the profit, or in this case, the area, so my dogs can play in a bigger area, right? We're trying to optimize that. You're trying to make a parabola, because then I know the max or the min is going to be at the vertex. And that's really easy to find. How do you find the vertex? Negative b over 2a, and then you can plug that in to get y. I like it. So if you solve this for y, throw it in here, distribute, we'll get a parabola. Find the vertex, you're done.
So y equals minus 2x minus 36?
Plus 36, right? Because subtract 2x, 36 is still positive, right? So you can say negative 2x plus 36, right? Because it's positive. Now throw that bad boy here, because you know that's what y is. It's like a system of equations. That's substitution, isn't it? Why is it a system? Because there's 1, 2 equations with 1, 2 unknowns. Holy shit. So really all I'm doing is substitution method, right?
And once I get a equals minus x plus 36.
No, careful. This is doing what to each other?
Multiply.
Multiply.
Oh.
Yep. You know you got to come out with a squared. So to be honest, even in pre-calculus, you're still going to need a squared to be able to do it by hand. One thing that calculus does for us is it's able to find, is this parabolic? Is that parabolic? No. Hell no. Right? So how do I find these maximums and these minimums? How do I do that? That's one thing calculus does. Because calculus is the study of, just bear with me for a second. I'm sorry, guys. Just bear with me. Study of slopes. Right? So here this is big positive slope. You with me? Here this is big negative slope. Right? You can imagine skiing. Big positive slope. Oh shit. Or you get on the little, take me up. And then here big negative. Holy shit. Right? So where is the slope? 0. Where's the slope? 0. Basically just gave it away. Slope is 0 like here, and slope is 0 at the maximum. Holy shit. So if calculus gives us a way to figure out the slope, we just find out where the slope is 0, and we can take any funky function and figure out where its max or mins are. Just by seeing where's the slope 0. Negative, positive, in the middle it must be 0. That's crazy. So for us, we don't know calculus. Jeff, we don't know calculus. Stop talking about it. Okay, I'm sorry. So parabolas, though, we can find that min or that max because we know it's the vertex. We don't need calculus for parabola. Anything else that's got a lot of humps to it, we need calculus. Good Lord. There's no negative b over 2a there, trust me.
Once we get the vertex, we put it in the y equals minus 2x.
Yeah, once you get the x piece, the negative b over 2a, right?
Yes.
And the question asks you what the area is, right? So you got to plug it back into your area formula. Yeah, or if you know x, you can figure out y and then just multiply them to get the area. Either way you want to do it. But the answer's got to be the area. X would just be how long this side is. Now, real quick, I mean, you've got all the answers right there. What was this again? Okay. So I think this is 9, 9, and 18, right? Yeah, feet. Do you see how, if it was a square with a perimeter of 36, it wouldn't have been 9, 9, 9, 9? Do you see how the side is not there? Do you see? So you see how that 9 got added to this 9? So it's still trying to make it a square. It's saying these guys together have to equal these guys together. Well, this isn't even there, so this one gets all of it. So it's not a square. It's a rectangle. I understand that. I'm not insane. But it still has a square kind of thing to it. It's trying to make it a square. I'll stop there. I'm sorry. You don't have to know anything of what I just said. That seems to be the theme of today, Jeff. But you have to know how to do this. They tell you something, you solve for a letter and plug it in there, so you get a equals negative 2x squared plus 36x. Now you know what b is, you know what a is. You can use a shortcut to get the vertex. So if I ask you, find the maximum profit or the minimum cost or whatever, you know eventually you're going to find a vertex. That's what you're going to do, because that's where the max or the min is for us right now. In real life, very often the formulas are a little bit more disgusting than just parabolic, right? But there are a lot of things that are parabolic, so it still works. Like this. The maximum height of the basketball, so it doesn't hit the girder on top. Yes, sir.
Oh, can you do 8 if?
Oh, good. I was expecting a question on that one. So there's one way I did it on the answer key. Holy crap, you really woke up. So one way on the answer key is, why did I make it related to 36? Because 4 goes into it. So you didn't even, I just wanted to show you some work. The way I really would do this is 4 goes into 38 with remainder 2, I squared is negative 1, I'd be done. I wouldn't show anything. I want to show you something. All right, so I of 36 is 1, because every fourth one, it starts over again at 1. I squared is negative 1. Cool. Another way to do it, I always forget to look to see which way the book does it. Another way to do it is to do it like this. 2 times 19 is 38, right? You don't have to do it this way. What's I squared? Negative 1. And what's 19 negative 1s multiplied together? Negative 1 still, because it's an odd number of negatives, so it's going to come out negative. So there's a whole other way to do it. All right, so to do it this way, if I had an odd number up here like 41, I could still do I squared to the 20th times an extra I, right? So then this would be negative 1 to the 20th, positive 1 times I, so the answer is I. But to me, 4 goes into 41 with remainder 1. I to the first is the answer, done. Next. You just got to know that cycle. I to the first, I to the second, I to the third, I to the fourth. Right? And if you just remember, here's I to the 0, I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, That's why every 4 kind of circles back to 1 again. Every 4 circles back to 1 again. In my first 110 class, I've explained that too. Hopefully it makes a little bit of sense. Because I love the idea. We already know that negative 1 is kind of like putting it on the other side of the number line. We just have to now think about, what about half a turn? What if it don't turn all the way? There's got to be, should be something there to make this a complete idea of turning. Yeah, there is. There really is. It really is there. We could actually teach this shit from the first time we teach you negative 2. We could start teaching I's. It's a little bit freaky though, so we decided not to. But they are there just as much as 7 is there. Oh, okay. So if I were a student in this class and matrices kind of bum me out, which I feel like basically covers everybody, but
I just don't know, like, the whole switching and the numbers you can't keep.
I got you. I would do that matrix problem. Wherever I put it in the test, I would do it last. Because I get students who like get stuck and they just can't let go and there's 50 minutes gone and they're still in number 1. Don't do that to yourself. Because the matrix, you make one stupid little mistake, and I understand you get, right, so do it at the very end. Trust me. So why don't I just put it as the last problem? I don't know. I'm just trying to teach you how to do a test. So here we got, how would the matrix look?
1, -2, 4.
Gotcha. Okay, so -2, 1, 1, -4, and then 5, 1, -3, 6. Okay, cool. I like it. Always double check. Yep, cool. Okay. Now, again, to be completely honest, you don't have to start with this column. I did on the test just because it's like standard textbook way to do it. But I actually have a 1 here and here. I have a 1 there. I could start with the last column if I wanted to. My point is, the main thing you want to do is to get a column, finish it. Move to another column, finish it. What does finish mean? Make it look like it's supposed to, right? Whichever column it is you're looking at. Right, whichever column it is you're looking at, make it look like it's supposed to. So do you want to, I could do it a different way than what I did on the practice test answer key. I've already got that there. Different way? Okay. Yeah, Matt, well, come on. So you guys help me out. Not column 1, column 2 or 3, which one? 3, okay. So in column 3, there's my 1. So I'm going to use that 1 to make a 0 here and a 0 there. Now, we'll deal with this in a minute. It'll be in the wrong place, won't it? But that's not a big deal because I could just switch those rows. Who cares? Right? So what do I do then? How do I eliminate the 4 above that 1? How do I kill this guy?
-4, row 2, plus row 1.
11. So -4, row 2, plus row 1. Put the answer in row 1. I like it, because that's where I want 0. I can do that. So then I get -4. So this will be 8, right? Just multiply each one of these by -4. Is that cool? So that's what I do in the parentheses, is what would it be if I multiplied by that? Because I only need it for a second. I would just divide it again. So why even write it for real? So 8 plus 1, 9. -4 minus 2. -4 plus 4. And 16 plus 8. Cool. Alright, because I'm just doing exactly what we saw we had to do to kill that. I got to do it with everybody. So there's all kind of, whatever happens to them happens. How do I kill this -3? Yeah, multiply this by this row by 3. Add it to row 3. Put the answer in row 3. So if I multiply this by 3, I get -6. You can just cross these out now. We don't need them. -6, 3, 3, -12. Cool. Really hope, is everybody with me on those numbers?
So you could choose where to put that.
Yeah, you can. In fact, right now, if I want, I could have put the answer in row 2 instead. But I really like that 1, so I don't want to do that. So -6 plus 5. -1. 3 plus 1. 3 minus 3. -12 plus 6. I like it. And then the middle row just stays the same way. 1, 1, -4. Okay. All right. Now, if you want to, just to keep track, don't I want to switch the second and third row? Because I want that 1 to be here, don't I? What do I want the last column to look like?
0, 0, 1.
0, 0, 1. So if I just switch those rows, it would look the right way. You can do that anytime you want to, just to make things, just so you can see clearly what else you got to do. All right, so just switch those. What can I do with the first? We might as well do this. What can I do with the first row?
Divided by 3.
Yeah, divided by 3. So I get 3, negative 2, 0, 8. Switch this over. Switch that one down. Okay, now, so I got that column done. Now I can move to either one of these two columns. There's a 1 there, but you see how that, I don't want to screw those zeros, do I? All right, so,
Did he switch again?
You just switch
oh,
to
these two here.
after.
Yeah, because I want that 1 right there, right? Bam, 0, 0, 1. 0, 0, 1. Cool. Now, I can't use this to kill these. Do you guys see why? Because that 1 would then screw with this 0. I don't want to lose zeros. I don't. That's the key. Don't do something that's going to make you lose a 0. So what I can do instead, I can look at this first column if I want to. Right? I can make the 0 here, I can make a 0 here. I can make a 1 here if I add row 1 and row 3. Right? There's a lot of different things I can do. Let me just stop right there. Let me let you guys catch up with my craziness. I want a 1 there, don't I? Dear God, don't divide by 3. Right? There was a few people doing that. I'm like, don't do that to yourself. I could force you to do that. You should be able to. It's fractions, who cares? But don't, my God. So I could either multiply row 2 by 3 and then add row 1 and row 2, put the answer here. Right? And then I could multiply row 1 by 2 and row 3 by 3 and then add these together. Do you see what I'm saying? I can make 0 and 0 fine. Right? All right, let me just do it. Okay. So if I do 3 row 2 plus row 1, put the answer in. Now, another thing I could do, I don't know why I didn't notice this. I could just switch these and have a 1 here. Couldn't I? That'd be nice. Yeah, exactly. Who cares if you turn these around? All right, let me stop. I'm just trying to show you more about what flexibility you have with these problems. All right, I feel like some of you guys might be feeling like, what the shit is all this? You can switch rows if something is looking like it's in the wrong place. So that 1 would be even better if it was up there, wouldn't it? Yeah. In fact, I can multiply through by negative 1. Switch it with row 1. That little, you see how that means switch? So that would be 1, negative 4, 0, 6, 3, negative 2, 0, 8, negative 2, 1, 1, negative 4. Okay. Now, you can use that 1 to kill that 3. You can use that 1 to kill that negative 2. So how do I use it to kill the 3?
Multiply by negative 3.
Yeah, multiply row 1 by negative 3, add it to row 2, put the answer in row 2. So if I multiply this one by negative 3, it's negative 3, 12, 0, negative 18. Negative 3 plus 3 is 0. That's crazy. 12 minus 2 is 10. 0, 0, 0. Negative 18 plus 8. Negative 10. That looks really, really nice. Now how do I kill the negative 2? I'm done with these. Let me just cross those out. Done with those. How do I use this to kill this? Yeah, twice row 1 added to row 3, put the answer in row 3. So twice row 1 looks like this. 2 minus 2 is 0. Negative 8 plus 1 is negative 7. 0 plus 1 is 1. 12 minus 4 is 8. And the first row is still 1, negative 4, 0, 6. So now you see how this column is totally done? This column is totally done. What happens here? Yeah, and then you get a 1 here that can kill that and kill that. Why is the 1 here so kick-ass? I call it a laser. Because there's a 0 there that won't screw with whatever's here, and there's a 0 there that won't screw. It's just the laser just goes right to where it needs to do something. I don't know if you guys really see what I mean by that. It's a laser. Why don't you in the laser get a room, Joe? So I can make this, can I just do that? Just to, right? Divide by 10? So now I can multiply this row by 4, add it to this, multiply this row by 7, add it to this. I mean, you guys, once you get 2 columns done, the last thing to do is normally pretty in your face. Let's see how I can do this. So if I multiply by 4, that'll be 1, 0, 0, 2. If I multiply it by 7, that'll be 0, 0, 1, 1, right? And then the middle row is still 0, 1, 0, negative 1. Oh my gosh. Oh, I see what happened here. You'll be alright. You'll be alright. Yeah, there you go. 2, negative 1, 1. Same answer, yeah. So it doesn't matter. So on the answer key, I just started with the first column, which you can always do if you want to. But if this was like 7, 8, and 13, I'm like, screw that. Let me just find a 1 and then start with that column. That'll make it a little easier on me. I can tell you guys love it. Yes?
So when we switch places, it doesn't matter for the X and Y and Z.
No. So I really want you to be careful. I would never switch like places like this, because then that screw. If I just switch like this,
Yeah.
all the columns still mean X's and Y's and Z's. I haven't switched the variables. It's like me writing equations in a different order. Does that change the problem? If I gave you a problem and I said, solve this system of equations, I gave this to you, and I gave this one to somebody else, are they given 2 different problems? I wrote one of them better, I know, but they're the same problem, aren't they? I just wrote the equations in a different order. The answers are going to be the same, aren't they? Right? If I write the equations in a different order, does it change the answers? Please tell me you understand that the answer to that is no. So switching 2 rows is like writing the equations in a different order. Who cares? But you would never do this, because that changes the meaning of the columns. And you pretty much always want to keep it X, Y, Z answer. Right? Okay. So just like before, with a matrix, what you want to do is, if you end up having to erase a few times, just make sure you get to some point where you've shown me enough work so I can see that you understand the process. I had people turning stuff in the quiz where I had a lot of erased stuff, but I didn't have enough to go on to tell that they know what they were trying to do. All right, so to me, the answer is the second most important thing in that problem. It's show me that you know what you're trying to do. Because I understand, you make one little negative mistake, and believe me, man, you do this with a 7 by 7 matrix, and you make one little mistake in the middle of it, and then your teacher's an asshole that doesn't give any partial credit. Oh, so I feel like I was just saying I walk uphill both ways, but so show me you understand what you're trying to do, and you'll get most of the points.
I have a problem with 16.
Okay.
I have to square 2 plus the square root of x minus 1.
Mm-hmm.
And when I fold them, I don't know what I'm doing wrong, but I get 4 plus 4 square root of x minus 1 plus another x minus 1. Square root of x minus 1.
4 plus 4 square root of x minus 1 plus...
The square root of x minus 1.
Oh, that's the problem. What's the square root of x minus 1 times the square root of x minus 1?
X minus 1.
X minus 1.
They come.
Square root's gone.
Oh,
Yep, I like it. I will tell you this, sometimes I have been known to put this kind of a problem on this test. Nowhere near as hard as you think. How would you do x squared minus 4?
Plus 2 minus 3.
Yeah, x minus 2, x plus 2. So how do you do x squared plus 4? X minus 2i. X plus 2i. We've looked at that before, to be honest, bless you. Because you still got minus 2i, x plus 2i. The middle terms still cancel. Well, what is, and you still got x squared. What is negative 2i times 2i? It's negative, what's 2i times 2i?
4.
4i squared. And what's I squared? Negative 1. So you get x squared plus 4. Right? So how do you factor x squared plus 9? X minus 3i, x plus 3i. See, adding the I at the end is what makes the sign change to positive. So you can't factor this using real numbers. You have to use complex numbers. Because complex numbers are the only things that when you square it, you get a negative number. It makes that possible to do. Cricket was just so appropriately placed there. So one thing you gotta be careful about is, I know I showed you on the calculator how to put, radicals in there. On the test itself, if I don't say use a calculator, I need to see how you get to the answer. So you gotta show me some kind of work. I love, there's a few people, and they don't get extra points or something, but there's a few people who are doing something like, this 81 is 3 times 3 times 3 times 3. I want 3 of them, so the answer is 27. Right, so that's one way to look at it. I've never had somebody actually take me up on that offer to do it that way. Because what's the other way to do this problem? What's the root? 4th root of 81, and let's put the third power on the outside because we're not crazy. What is the 4th root of 81? What does it take 4 of to make 81? 3's. And what's 3 cubed? 27. I like it. So that was the other way. 3/4 of 81. 3/4 of 81 is 27. So 2/4 of 81 would be 9. And 2/4 is 1/2. Square root of 81 is 9. I like it. I like it. Do you have to do it that way? No. If you don't do it that way, well, I hate you? No. Yes.
So I have a question from the test correction for the last test. So these two, the word problems, like I try hard and is it the
How many players are there? How many parts of this problem are there? There's the longest side. There's a shortest side. And there's middle side, or what do you call it? Middle side. You got to figure out which one's just X first, right? Which one do the other two depend on? Right, so you write middle, longest, shortest. Which one do the other two depend on? The longest side is blah, 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 related to what? The shortest side is blah, blah, blah. Right? The longest side is 5 feet shorter than 3 times the shortest. The middle is 2 feet longer than the shortest. They both depend on the shortest. So call him X. He gets things going. So if you call the shortest side X, the longest side was what again?
5.
Yeah.
5 feet.
5 feet. Keep going.
Well, 5 feet shorter than 3 times.
Ah. So if you call the shortest side X, 3 times the shortest side is 3X. 5 feet less than that is 3X minus 5. So now you have an expression for the longest side. Now make an expression for the middle side. And then all 3 of them are supposed to add up to be what? The perimeter.
The other one will be 2x plus 5.
Yep.
Okay.
Now add all 3 of them to get the perimeter, yeah. So you got the test corrections are due on Wednesday. The quiz corrections are due on Wednesday. You can still turn them in after Wednesday. It's just the later it is, the less points you can get back. So this one's for quiz.